My name is Jason Triefenbach. I am an emergency mitigation planner with a Master of Science degree in Emergency Management and Community Resilience from Portland State University. Today I'm talking on cultural heritage and climate change, considerations for research and planning. The effects of climate change on the preservation of cultural heritage assets is increasingly seen as a central concern for adaptation and mitigation planners, cultural resource managers, and invested stakeholders. In this presentation, I investigate these effects and some ways in which researchers and policy consultants are framing the issue by reviewing 4 research studies and applied methodologies conducted at both localized and dispersed geographical scales. Comparing this data to identify similarities and trends, I categorize commonalities among the studies and offer concluding thoughts and suggestions for the field. So the 4 papers in question are Climate Change Impacts on Cultural Heritage, a literature review, Cesana et al., 2021. Of Time and Tide, the Complex Impacts of Climate Change on Coastal and Underwater Cultural Heritage, Gregory et al., 2022. Heritage and Climate Planning, the HiCLIP Pilot Project for Understanding the Integration of Culture into Climate Actions, etc., Guzman and Daly, 2021, and Effects of Climate Change on the Future of Heritage Buildings, Case Study and Applied Methodology, Huerto Cardenas et al., 2021. Some of the topics considered in the readings are both outdoor and indoor archaeological assets and the effects of various climate change-induced weather hazards on tangible and intangible heritage resources. 2 of the 4 papers looked at deficits through a rubric of chemical, biological, and mechanical degradation, and a third took an almost identical approach by applying categories of physical, chemical, and biological deterioration to the author's analyses. Quite interesting, I think, is that 2 of the papers propose analytical methodologies for deployment by heritage managers, climate scientists, potentially, public stakeholders as well. Here we have one of Guzman and Daly's elegant flowcharts examining the ways that cultural resources are referenced in various climate plans around the world. And Huerto Cardenas projecting deterioration rates of painting varnish, as well as using baseline temperature and humidity readings in the Duomo de Milano in Milan, Italy, to predict future possibilities of mold growth on the interior of the building. After beginning with Cesana's lit review, which considered both interior and exterior assets, I made sure to include Huerto Cardenas because of its focus specifically on an interior asset collection, and then followed that up with Gregory et al. 2022, which focuses mainly on exterior assets and degradation scenarios. All of the papers acknowledge that climate change accelerates and intensifies the adverse effects of weather on tangible heritage sites, and all call for greater interdisciplinary collaboration to solve the mounting potential for climate heritage crises. Looking at this through a pre to post-disaster timeline, we first see the heritage assets in a pre-disaster baseline state. Then through the sudden or gradual external stressors of climate change-induced weather hazards, these assets enter a post-disaster degraded state, which may be chemical, biological, or mechanical in nature. In trying to wrap my head around all of this and maybe even come up with some of my own positions on the matter, I've created a quick filing system with categories of geographic context, hazard typology, indoor-outdoor considerations, categories of degradation, analytical methods, and interdisciplinary solutions. Geographic contexts range from Cesana's broad data sets from across climate zones and within a complex topology of different stressors, and Guzman and Daly's report on HiCLIP's pilot project assessing climate plans at different governmental scales internationally, to Huerto Cartenius, which again developed a method for predicting heritage continuity deficits in the Duomo de Milano, which is not only as a building a cultural asset in its own right, but which also houses a collection of precious artworks important not only to Italy's history and culture, but also to humanity's collective heritage. The ecological impacts of climate change on the world's oceans and coasts is well documented. However, less has been said thus far about how these changes have affected, are affecting, and will affect coastal and underwater cultural heritage sites, which is the focus of Gregory et al.'s 2022 paper. What I've characterized as hazard typology includes the effects of gradual natural processes as well as sudden changes from catastrophic weather and geomorphic events, all of this exacerbated by climate change. Gradual stressors on outdoor tangible heritage break down as changes in temperature, precipitation, and wind speed and direction, while sudden changes come about through storm surges, floods and landslides, wildfire, sea level rise, permafrost thaw, desertification, and changes to oceanic properties. I won't go through all of the details on this particular slide, but come back in the video and pause on this frame if you're interested in looking at some of the particular consequences of some of these different scenarios. We can begin to deduce overall how outdoor conditions can have a significant impact on indoor heritage assets, with consequences to paper collections, archives, frescoes and murals, wooden panels and furniture, fabrics, costumes, and much more. At the Duomo de Milano, changes to temperature and humidity can be of concern for paper collections, the varnishes of paintings, mold growth, and other contaminating influences to buildings, collections, and even the health of staff and visitors. Categorizing climate change-induced degradations as mechanical, chemical, or biological allows for a certain specificity in problem solving. For instance, mechanical degradations might include structural damage, like the swelling and contracting that wood goes through in changes in humidity. Chemical degradations could include damages resulting from ocean acidification and chlorination, as well as reactions at large to temperature and humidity changes. Biological degradations might include mold growth, but also increases in insect and rodent populations, as well as particulate matter in the air and changes and increases to human health risks. Anthropogenic climate change alters natural deterioration processes, intensifying degradation to cultural resources and aggravating the physical, chemical, and biological structures of the affected objects. In terms of analytical frameworks, the four studies provide a rich cache of data for practitioners and researchers in a number of fields and potential sources of inspiration as well on how to think about climate change effects. Collectively, the papers present a diverse portfolio of data visualizations and connective frameworks, drawing from the international literature, global surveys of professionals, biome-specific and site-specific data collection, atmospheric measurements, integrative coding, and mixed methods monitoring and assessment to examine the level and focus of current CRM integration into generalized climate planning for a more informed perspective on the complex interplay of human and natural systems and how that impacts cultural heritage management, and formulating best methods and actions to confront these issues. There is a growing body of research on the intersections of climate change and heritage preservation. Many authors, however, found a lack of scalability in projects and a saturation of single scenario studies. A need was recognized for greater integration of what Guzman and Daly call culture-related expertise, as well as more interdisciplinary understanding and a greater inclusion of cultural elements in localized, local-level climate planning. A variety of motivations exist for such interdisciplinary collaboration, including not insignificantly the hope of a development of toolkits to aid and encourage greater integration of these aims and areas of expertise. My sorting system, tabulated from the data above, accounts for types of disasters and processes that pose a risk to cultural heritage, sites, and assets, as well as innovative methodologies for combating these problems. My conceptual rubric leads me to suggest a number of conclusions. Cultural resource management has the potential to effect positive gains in public health equity, disaster mitigation planning, and community efficacies. Interdisciplinary collaboration is a stated goal across all scientific disciplines, yet efforts and results to this end are mixed. A need exists for synthesizing adaptation and mitigation efforts across local, regional, national, and global scales. The environmental movement has been around long enough to have become a multi-generational social reality and can itself be afforded the status of a non-material cultural heritage resource. Further study on its treatment as such by museums, research entities, governmental bodies, and vernacular place-specific groups is warranted. This project joins my concurrent research on green infrastructure planning and public health equity, along with past work on environmental justice and parkland services and sense of place values in Portland parkland soils, and a developing portfolio of research interrogating community resilience and coupled human-natural systems. Thank you for listening, and please feel free to get in touch.